Good morning. Again, Dr.M.EZHILAN speaking. Now we will continue the basic of the thermodynamics. First of all, heat. What is meant by heat? Heat is a form of energy. Already we know that, which transfer without transfer of mass from one body to another body, from higher temperature to lower temperature by virtue of temperature difference between two bodies. The heat is abbreviated as capital Q, and the unit of the heat is joule. Here the heat addition into the system is we have to consider as a positive sign. The heat rejection from the system we have to consider as a negative sign. Extrinsic properties and fourth function is considered in exact differential. Next, we have discussed about work. Analogues of heat work is also a transient form of energy which is observed when it crosses the boundaries of the system without transfer of mass. It is fourth function, small work done due to a displacement. So delta W equal to F into ds. Total work done W equal to integration of 1 to 2 limit F into ds. Next we have discussed about what is the difference between heat and work. Heat can only transfer when there is difference of temperature between the system and surrounding, while work transfer can take place even without the change in temperature. Second one, in constant volume process through work cannot takes place. However, heat can be transferred. In case of work transfer, its sole effect could be raising or lowering a weight in the surrounding, but in case of heat transfer, other effects are also observed. Then, similarity between heat and work. First one, both heat and work exist in transit, and these are never possessed or contained in a system. Second one, both heat and work refer to boundary phenomena. Third one, both heat and work are path function and do not represent as the properties of a system. Next, enthalpy. Enthalpy is nothing but it's a total energy of the system. The enthalpy is a point function, so H is a symbol of the enthalpy. The unit of the enthalpy is kilojoule. Unit of specific enthalpy H equal kilojoule per kg. Enthalpy capital H equal to capital U plus PV. Small h equal to small u plus PV. Next, first law of thermodynamics. Energy can neither be created nor destroyed, but it can be converted from one form to another form. This is the energy conservation law. Now we have discussed about first law of thermodynamics. First law of thermodynamics applied to closed system. A cyclic process. If a closed system goes through a cycle The algebraic sum of the total energy transfer to its as heat and work is zero. Here the cyclic integral of delta Q minus delta W equal to 0. That means cyclic integral delta Q equal to cyclic integral delta W. Limitation of first law of thermodynamics. First one, no restrictions on the direction of the flow of heat. The first law established defined relationship between the heat absorbed and the work performed by a system. The first law does not indicate whether heat can flow from a cold into the hot. For example, we cannot extract heat from the ice by cooling it to a low temperature. Some external work has to be done. Second point, does not specify the feasibility of the reaction. First law does not specify the process of feasible or not in, for example. Third one, practically it is not possible to convert the heat energy into equivalent amount of work. This is a first unit of the basic of the thermodynamics. Okay, we will see the second unit. Thank you.